So in this example, the problem is to divide two rational expressions. In this example, those expressions happen to be involving multivariate monomials. In other words, we have two different variables in here. We've got some y's and we've got some a's, and they're monomials. We don't have any addition or subtraction or anything going on inside of our fractions, which is going to make life maybe a little bit easier because the factoring steps that we otherwise would have had to do are a lot simpler to do. We can already see what the factors are. But the same strategy that we're going to talk about works when you have polynomials upstairs and downstairs as well. So what's the strategy? How do you divide two rational expressions? Well, how do you divide two fractions? If you can answer that question, then you know what the overall strategy is for rational expressions as well. How do you divide fractions? You flip and multiply. Right? You multiply by the reciprocal of the second fraction. Flip the second fraction and turn the division problem into a multiplication problem instead. And we know how to multiply two rational expressions now. So let's take a trip down memory lane and think about dividing fractions again. If I have the problem like 5/16 divided by 11/20, how am I going to do it? Well, I know that to divide two fractions, what I really want to do is to take that second fraction that we call the divisor, 11/20, and replace that second fraction by its reciprocal. Turn it upside down. And when I turn the second fraction, when I turn the divisor upside down, replace it with its reciprocal, I thereby trade out the operation of division for the operation of multiplication. So we're just passing through the looking glass. We'll flip the second fraction upside down. That flips the division into a multiplication. And now I have a problem which is no longer a division problem, but a multiplication problem instead. And since this is a multiplication problem, I know what to do because I know how to multiply fractions, or in our later example, rational expressions, right? We know how to multiply. We just multiply by multiplying straight across. Multiply straight across the numerators, multiply straight across the denominators. Don't worry at that stage about factoring, canceling, any of that stuff, because that's what we do next. After we've multiplied across the numerators and denominators, 5 times 20 over 16 times 11, then we're going to look for what we can cancel. In other words, we're going to simplify this fraction into its lowest terms. How do we do that? By factoring everything in sight as much as possible. Right? So identify, in this example, all the way down to the prime factors, what it is that make up the numerator and make up the denominator. Well, 5 is a prime itself. 11 is also a prime itself. But 20 is 2 times 2 times 5. 16 is 2 times 2 times 2 times 2. So now we've completely factored everything upstairs and everything downstairs. And the purpose of factoring is to identify what we can cancel. So find anything which is common to the top and the bottom and get rid of it. What can we get rid of here? Well, we have one 2 that we can cross out from the top and the bottom. We have a second 2 that we can cross out from the top and the bottom. But then that looks like it, right? The top now has only 5s left. The denominator has a couple of 2s and an 11, so there's nothing that's common now to the top and the bottom. So that's as much canceling as we can do. So then it's just a matter of simplifying out the product of what remains. So we're going to multiply back out and simplify. We had 5 times 5 survived in the numerator. 2 times 2 times 11 survived in the denominator. So what we really had was 25 upstairs and 44 downstairs. So the quotient of these two fractions is 25 over 44. That very same overall strategy works to divide two rational expressions. Instead of dividing, take that divisor, the second fraction, flip it upside down, replace it by its reciprocal, and change division for multiplication, because then we know how to multiply one fraction by another. So let's do it. Instead of thinking about 2y over 3a divided by 10y to the 5th over 9ay, we'll flip that second fraction, replace it by its reciprocal. And when I do that, I'm also replacing division by multiplication, which is great, because again, we know how to multiply. So the multiplication problem, whose answer is going to be the same as the division problem that we started with, is the multiplication problem 2y over 3a times 9ay over 10y to the 5th. If I can multiply these two rational expressions, then I've got my answer. How do I multiply rational expressions? Straight across the numerators and straight across the denominators. Upstairs, 2y times 9ay. Downstairs, 3a times 10y to the 5th. Now that we've multiplied those out, we need to know how to simplify. And simplifying requires us to answer the question, what cancels? Well, we don't know what cancels until we know what the factors are. So we'll factor everything in sight. 2y and 3a are as factored as they're going to get. 9ay is 3 times a times y. 10y to the 5th is 2 times 5 times then 5 factors of y. I'm being a little bit brutal here about factoring everything out completely, but it might help us to understand what comes next. So we factored everything completely, and any factor which is common to the top and the bottom can be reduced. So what cancels? We can cancel a 3 because there's a 3 on the top and the bottom. We can cancel a 2 because there's a 2 on the top and the bottom. I can cancel an A because there's an A on the top and the bottom. I can cancel a Y because there's a Y on the top and the bottom. I can cancel one more Y because there's another Y left on the top and the bottom. But then I run out of things to cancel. Upstairs, the only thing left is a 3. Downstairs, the only thing left is a 5 and then 3 factors of Y. So at that point, I've done all the canceling that I can possibly do, and it's just a matter of re-simplifying back out what we have. Upstairs, there's nothing we can do with that 3. Downstairs, we can replace the 3 factors of y with y cubed. And so the quotient of these two rational expressions is 3 over 5y cubed. So don't let division throw you. Every division problem is a multiplication problem in disguise. All we have to do is flip that second fraction and turn division into multiplication. If you remember to do that step first, then from there on, it's just a multiplication problem. I mean, we know how to multiply rational expressions. Multiply straight across the numerators, straight across the denominators, and then set about simplifying by factoring everything that you can factor, canceling the factors that are common up and down, and then simplifying back out the product of the factors that remain.